invent your screen. Okay, so first things first, we put the number of diamonds on the row. 3, 4, 5. Then we count the number of toothpicks. It's 8, 15, 22. Then we see that it's plus 7, plus 7. Then we can get these. Plus 7, plus 7. Then here we get A1 equals to 8, A2 equals to A1 plus 7 equals 15, A3 equals to A2 plus 7 equals to 22, A4 equals to A3 plus 7 equals to 29, and A5 equals to A4 plus 7 equals to 36. So then we can say that the first hexagonal diamond is constructed using 8 toothpicks followed by 8 toothpicks and each additional diamond also needs 8 toothpicks. However, every 2 diamonds share a toothpick. Thus, every diamond needs 7 toothpicks except the first one to be constructed. Then from here, from the difference here, we can see that an plus 1 equals an plus 7. So now we can do that too. Now we can color code this, so we can go to that. So it would be here A of 1 equals 8. So these are the 8 toothpicks that we have in the beginning. And then we have A2 equals to A1 plus 7. So this 7 would be the 7 additional toothpicks that are here. And these are the initial 8 for A1. So then A3 would equal to A2. How do you do it like that? A2, let's say A2 is going to be all of these. And it would be plus 7. So these 7. Now here, hold on. Draw, select, insert picture, this device. We need to draw or sketch what it will look like, what figure 4 would look like, which is here, I already did it. And we can do it for these. Draw. So for this one, this 8 is going to be the 8 initial that we have, which is going to be for all of the figures. All 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we have plus 7, which are the C7 of each one. But it's 7 times n minus 1, so it'd be the groups. So we have, for a equals 1, we don't have any groups of 7. Let me explain this. Let me just select, need space. So for an of 1, we just have 8 plus 7, 1 minus 1. Since it's n minus 1, we have 1, that equals to 0. 8 plus 7 times 0. So we have no groups of 7. So then A2 would be 8 plus 7 times 2 minus 1. It's n minus 1, and here is 2. So it would be equal to 8 plus 7 times 1. Here we have one group of 7. So we have 7. We have one group of 7 here. We can see it here in the 8, the initial 8 we have. And we could do that for A3 equals to 8 plus 7 times 3 minus 1. Here, and it's 3, so 3. From over here we have 3 minus 1. 8 plus 7 times 2, since 3 minus 1 is 2, and we can see 2 groups of 7. And then here we have, you can't see them, but we have the 8, which is the initial 8 we started with. Then we have the plus 7, which is the number of sticks for each additional diamond. We have n, the total number of diamonds, and we have n minus 1, number of additional diamonds. So that's for D. Now for E, let's also insert the picture, this device. So for this one, we have here we have n equals 1, n equals 2, n equals 3, and n equals 4. And these are going to represent this n. And then the 8 is going to be this 8 is the initial 8. And every 8 that it takes to do on every single diamond. So here it would be 1, 2, 3, 4, 5, 6, 7, 8. And here we would count this one twice for 8n. 1, 2, 3, 4, 5, 6, 7, 8, and so on for all of them. So this one would be 8, 2, 3, 4, 5, 6, 7, 8, and 8, and 8, and 8, and 8, and 8, and 8. But then we would have n minus 1. This n minus 1 represent the shared toothpick that each one has. That when two diamonds are next to each other that they'll have. So we can see this by doing A1, we know equals to 8 times 1 minus 1 minus 1, which is b equal to 8 minus 0, because there are 0 shared toothpicks. Then for A2 equals 8 times 2 minus 2 minus 1, since A2, this 2 is in, so then minus 2 equals to 16 minus 1. This 1 represents the red, this red one, this shared toothpick that we have here. Then for A3, we have 8 times 3 minus 3 minus 1 equals to 24 minus 2. Then for A4, we would have 32 minus 3, since 4 minus 1 is 3. So then we can see that 2 is these 2, and these 3 is these 3 that are shared here. So we can see that AN is 8 times the number of diamonds. You can see that 8 times the number of diamonds. 8 is the number of toothpicks for every diamond. N is the number of diamonds. So AN is the number of toothpicks per diamond times the number of diamonds. And n minus 1 would be the number of shared toothpicks. So there we go. Now let's go to letter F. So here we need to post also the figure all the way to figure 4. So again, I just go in here. This one, insert. So here we have 3n plus n plus 1 plus 3n. So this first 3n, we're going to do it for this triangle on top for all of them. So these 3, I'm doing that. These 3, these 3, these 3, these 3, these, and these, and these. Then this 3n is going to be these 3, these 3, these 3, these 3, these 3, and these 3, and so on all of them. And then this n plus 1 would be the number of toothpicks that it takes to connect the bottom and top triangles. So here we go. And then we can see this by doing A1 equals to 3 times 1 plus n, which is 1 plus 1 plus 3 times 1. We see that by 3 plus 2 plus 3. So this 3 is going to present the red ones, the 3 on top. This 3 is going to present the ones on the bottom, these on that picture. And these two is going to present the 2 lines that it takes to connect the 2 triangles. And then we can do that for the rest of them. Here I'm just going to do a 2. So we could do 3 times 2 plus 2 times 1 plus 3 times 2, which equals 6 plus 3 plus 6, which here it equals to 8. I can see this one equals to 15. And we can see that first red, this 6 represents the 6 on top that it takes to make the 2 triangles. This 6 represents the 6 on bottom that it takes to make the 2 triangles. And these 3 is the 3 lines that it takes, the 3 toothpicks that it takes to connect the 3 triangles. And you can do that for A3 and A4 too, to see that here would take 9 toothpicks on top and 9 toothpicks on bottom, and then 4 here, and so on. And now we can write the elements that we use. You have 3n. Wait, first we have n, which is a number of diamonds. Then we have 3n, which is the number of toothpicks it takes to make the triangles in the bottom and top times the number of diamonds. And we have n plus 1, which represent the number of toothpicks it takes to connect the triangles on the bottom to the triangles on top. And there we go. That's it. Yeah. That's all we have to do.